right, so our next problem is iron oxide reacting with aluminum. So we have iron 2 oxide 3 plus aluminum, and these are both in liquid state. And that turns into, or reacts into, aluminum oxide in solid state plus iron, and it remains in its liquid state. Now, before we start moving on, we actually have to balance this equation because the equation asks for it, and we'll get lost if we don't balance our equation. So we have 2 irons on the right and left, and 2 aluminums on the left and right. So now everything is balanced. Now we can begin our work. We have 175 grams of aluminum of iron oxide, and we have 37.5 grams of aluminum. Now I can't just say this is a limiting reagent because aluminum is smaller or iron is bigger. I actually have to work out the formulas. So we have here, first we'll work out with aluminum because that's a bigger one. So we have 37.5 grams of aluminum, and we multiply that by 1 mole over the mass of aluminum, which is 26.98 grams of aluminum. Grams cancel out, which gives us 1.39 mole of aluminum. So that's our first part, still not done. We need to change this mole into iron because we're going to find out for iron. We're looking for how it relates to iron in moles. So we have to multiply 1.39 mole of aluminum times that by 2 moles of iron, because our ratio is 2 irons in this equation, over 2 moles of aluminum, since we have 2 moles on the other side as well. And that gives us 1.39 moles of iron. Now that we finished the aluminum and we have our relation to iron, this is our first part for iron. So it's 1.39 moles of iron. Now we have to find out how many moles of iron oxide we have. So we have 175 grams of iron oxide. We multiply that by 1 mole of iron oxide over the mass of a mole of iron oxide, which is 160 grams of iron 2 oxide 3, and that equals 1.09 mole of iron 3 oxide. We can't just start working with this moles. We have to find out the moles of iron inside this entire iron oxide. So what we then have to do is we have to grab the 1.09 moles of iron oxide, multiply that by the 2 moles of iron in our equation, 2 moles of iron over the 1 mole of iron oxide, because that's what we want to drop. Iron oxide cancels out. We then end up with 2.18 moles of iron. As you can see, this number is bigger than our moles for aluminum, and thus aluminum is our limiting reagent. That is our first part. Now, also included in this question of question number 59 of chapter 9, section 8, is how much iron is produced from this equation. And what we have to do is we have to take our limiting reagent, which is our smallest ingredient, and since this one runs out first, we want to find out how much iron is produced with this ingredient. So what we do is it's 1.39 moles of iron, and then we multiply that by the mass of iron, which is 55.85 over 1 mole of iron, and that is equal to 77.6 grams of iron. And that's how many grams of iron are produced in this equation, with aluminum being our limiting reagent, 77.6 grams of iron.